All right, we have our project repository on gitlab.com, and the project is already empty. There is nothing in the repository. For adding the files to the repository, there are plenty of options. The first one is if we have a Git repository on our own local machine, we can use this instruction to push our code to the repository by this instruction. Or if the project has the files, we can clone the project to our local computer using these addresses for cloning the project. Or we can use the built-in web IDE in the GitLab to edit the project and add the files. For demonstration, I can use the web IDE, which is a version of Visual Studio Code by Microsoft. It's very familiar if you are using Visual Studio, and below we can see what branch at the moment we are in. And what I can do here, I can create to add new file, and I can name it readme.md. And as far as I do changes in this project, I can commit the changes here. I can call it initial commit and commit it to the main branch. So it is all set. So if you're curious about adding automation to our repository, we can use the GitLab CI feature to do some computation on each of the changes that we have in this repository. If I refresh, I have to see the README file that we have added in a few seconds. And now for the automation or the continuous integration, or we can call it GitLab CI, all we need to do is adding a file, and the name is really important, and the name should be .gitlab-ci.yml. So the dot in the first character is really important. Also, it should be YML, not YAML. So this is the configuration of the CI, GitLab CI, that we can write here. So we start very simple. All I need to do is just let me do some changes in the setting of the editor. I can increase the font size and I leave everything as is. And all we need to do here is we can start by adding a job here. Don't worry, we'll talk about the job, what is the job, and in details very soon. So I can add a job. The name of the job is optional. We can name it anything that we need. And the second part is I can start with a script, and the script should be a list of commands. So the tabs in the YAML file is really important, because when I hit the tab for the app build, it means that the script is an object, is a property of the app build object. So the script has a list of commands, and a list starts with a dash and coming with a space. So the space after the dash is really important. And I can add a very simple Linux command here, something like the generic word of hello world. And that's it. I created a job, and also the script is just one line of script and echoing a word here. All I need to do is just committing these changes again, and I can call it a very horrible commit message. Push it, yes, continue. And let's back to our project. As soon as I created the GitLab CI file, the YAML file, you can see there is an indicator here. It is indication of the pipeline. and the pipeline is already failed. So there is a message here: before you can run pipeline, you need to verify account. So this is something that need the verification, because previously some people use the free computation service of GitLab for doing some mining for cryptocurrency, and that's why the GitLab created this part for authorization. So I pause the video and I verify my account and I come back to the rest of the tutorial. All right, I did the verification. Let's go back to the project and let's do some changes and committing again, change. And let's go back to the project. Okay, the pipeline is running. Let's click on the pipeline. And as we can see, there is 3 tabs here. The first one is the pipeline, and there is a stage here, and the stage is test, and there is a job in this stage. So this is a stage, this is the job, and the job is the code that we have created here. This is a job, and this is the script related to the job. And it's all running. Let's refresh the page, and it was successful. If I click on the job, I can see the details about the job. And the job is running by a separate server. And let's check what are some of the details about the GitLab runner that is running this job. It is running our code in a Docker executor, and the base image that the Docker is using for processing our code is Ruby 3.1, but don't worry, it's not something important that we have to talk about. And also, after preparing the Docker and pulling the Ruby image, which is by default used by the in GitLab runner, the GitLab runner fetched the entire code from the repository, and the entire code is just 2 files that we have, which is very fast to be fetched. And after a while, the code that we have mentioned in the editor, which is this line, is executed and the message is printed out here. And because all the steps run without any error, finally the GitLab runner posted job succeed. So the process here, or the architecture, is that when we do some changes to the repository, suppose that, let's say, and refresh here, I have some files in my repositories. As soon as I do some changes in the repository, like pushing the code to the repository or editing a code and committing changes to the repository, GitLab will create, based on the instruction that we have defined in GitLab-ci, will ask the GitLab runner, which is a separate service, to run the codes, and the codes is mentioned here. And the gitlab.com or GitLab is the commander, and GitLab runner is just the executor of the code. GitLab runner will execute all the codes, and if there was no error, the finally the GitLab runner will say the job is succeed, and sends a message to GitLab service and says, okay, this job is successful, you can continue. So the GitLab service, as let's check the pipeline, the GitLab service will mark this job as succeed and will continue if there are other jobs or stages here. So let's continue. Let's add another part here. Let's say I can add another a script or Linux command here. Let's say I can create a directory here, like the build directory, and also I can change the directory to build. And let's say we can create a file here, touch app.yml, zip or let's say txt here, and let's commit the changes. I committed the changes without a message. That's fine. And let's come back to our project again. And there is a job running again. If I click on the pipeline, there is a pipeline, there is a stage with the name of the test, and also the a job is running. If I click on the job, I can see that it is in progress, and we have to wait for a few seconds. And also in the sidebar, there are some information about the runner, the timeout of the runner. The runner can execute a job for max to 1 hour. If we have a job which is takes more than 1 hour, definitely the runner cannot handle that. And okay, the Docker executor is using again the image Ruby 3.1, and also the messages is printed here, and also the directory and the text file is created here. But something that we have to keep in mind is that if I come back to my project, there is no text file. We created a folder like the build or the text file, but there is no file created here. The point is that when we create some files and commands in a GitLab CI service, these processes, these executions take place in another service. So it's something separated and is not related to here. So the codes in the repository are defining the code for our projects, and we are defining the steps of execution here. So all the processes that are taking place here are running in a GitLab runner, in a Docker container, in another service. So keep in mind that these files cannot be generated in our repository. And let's come back to our project, and let's add another job. Like, let's call it this time app test. And in the test, all we need to do is just hello from test, and we can get rid of the other lines, and I can commit the changes, commit the changes, and what we have here is just two jobs, and both of the jobs can be run simultaneously and concurrently in our pipeline. If I click on my pipeline, I can see that we have two jobs in a stage and they are running in parallel. So if we have some jobs that are not related to each other and can be run in parallel, we can put them in a stage. And the question is that what is the stage? Default GitLab has 5 stages. Let's say we can define the stages here. Let's say stages, and the first one is test, as we have in here, and the other one is the build, and the other one is deploy. So these are the stages that are defined by GitLab by default. But for demonstration, let's say I can define another custom stage. Let's call it custom stage, and I can assign the name of the stage to my job, and let's say stage custom stage. And also I can assign the other part to nothing. I can define nothing here. So by default, if I don't specify a stage here, GitLab can assume that this job is related to the test stage, which is the first stage that we have. Let's commit the changes and see what's happened on the project. Open the project in new tab and head over to pipeline. And as far as we expected, there is a new stage is custom stage and another stage is test. So everything is all set, and if I remove the test, I can call this stage for building to build, and I can call the other one stage to test. So if I don't define the stage for these two jobs, GitLab will assume that it is related to the test stage. So what I'm doing here, let's test it again, and without a message, let's check the pipeline. And as we can expect, we should have two separate uh, stages here, test and build. And the most important part is that if we define some jobs in a stage, the jobs will be executed in parallel. But when we define some stages, the jobs in a stage should wait for the previous stage. So all the jobs in the test stage should be completed, and then the job in the build stage can be started. As you can see, it was all set, and now the job in the build stage is running. Previously, it was pending for the completion of the test stage. And that's the power of chaining the jobs in a single file of GitLab CI. So let's change the file. And the interesting part is that when we are running our Linux commands, we are using a Docker image. There are scenarios that we don't need a Ruby image, or we need a specific Docker image. For instance, we have a Node project and we prefer to use the Node Docker image. And this is something really simple in the GitLab CI. All we need to do is just defining the image property here, and I can name the Docker image that I need to use here. I can use the Alpine for build, which is Alpine is a very lightweight Linux Docker image that is executes very fast and is really efficient for testing purposes and CI/CD and jobs. And also, if I don't define the image here, it will use the image that is the base image of the GitLab runner. So here, the base image of the GitLab runner is Ruby 3.1. And what I can do here, I can define whatever Docker image that I need, and I can call it Ubuntu, and also I can define the specific version of Ubuntu if I care about it. I can define the version here, but I leave it as is, and let's commit the changes again and go to project and check the pipeline. Let's check the pipeline, and as we can see, the job in the build stage is pending. Let's create the first job that is running, and now we expect that the first job, which is the test one, because the test stage is defined in first stage, because the test stage is defined here in top priority, and the second one is build. So this is the order of execution of the stages. And so the first stage is test, and the job related to this stage is app test, and the image is Ubuntu. Let's check here, and the image is Ubuntu, and the message that we have on this stage is here. And the final part is that so far we are familiar with the stages, defining some build steps and also defining a test. And let's add another test here because in the stage of testing we want to have multiple tests. The second test is echo test 2 and let's call it 2, and also let's change the order of stages here. Let's put the build stage in the first place and test and then deploy. So what we expect here is that the stage of build should be run in the first place. It contains only one job, and also in the second part there are two jobs related to the second test stage, and they will be executed after the completion of the build stage. Let's commit the changes again and switch to the project, opening the pipeline. And as we can see, the build stage is running in first place and only one job is related to this stage. And the second stage and all corresponding and related jobs are pending for completion of the first stage. And now all the jobs in the second stage are running in parallel. So let's check this one. The Docker image in build stage is Alpine. And let's check the other steps. And the Docker image is Ubuntu and test2 is here. All good. And for final part, let's have a real world test. Let's check. In the first place, we created app.txt in the build directory. And for a test, we can check if the file, testing if the file exists in the build slash app.txt directory. So this is a real test if the build file is available in the directory as well. But the problem is that each of the jobs will be executed in a separate Docker container. And as we know, the Docker containers will be executed in an isolated environment. So the file that the first container created is separated and isolated in another directory, in another environment. So the test part, which is executed in another container node, definitely doesn't access to this directory and this file. So this is something that is really useful and very important to know. To check, let's again do the commitment and let's check the project, and we expect a failure in the final part of the test. So the build will be executed, successfully executed. The second test is failed. Let's check what happened here. You can see that exit code 1. The GitLab runner can communicate with the GitLab service with just throwing exit codes. Every exit code other than 0 is indicating that the job is failed. Exit code can be 1 up to 255. So if the code was 0, means everything is fine, job is successful. And if there was an exit code more than 0, it means that there is a problem. And definitely, as we expected, there is a problem because the file is not shared between the jobs. So this is a problem, and we need a method or the solution for this. And this is something that is addressed in GitLab, very simple, and it is named artifacts. Artifacts is something like the volumes in Docker word, and we can keep some of the generated files consistent in our service. So all we need to do here under the app build, we can add artifacts, and we need to add another property for the artifacts name pass, and the pass is containing a list of directories. I can call it build directory. What I'm saying here is that just build after generating the build directory and creating an app.txt file, just keep the build directory and share it across all the jobs. And what the runner do after executing the code, it will send this directory, it can be a directory, it can be a file, sends this directory to the GitLab service, and GitLab service will keep this file or directory in artifact repositories. And other jobs that are running after this job can access to these artifacts directory or file as well. So it's all set. Let's commit the changes, and let's commit the changes and see what's happening. All right, let's check here. There is a pipeline editor here, and the problem is RT. Yeah, there is a typo here. Okay, it's my bad. Artifacts. It's artifacts, and let's build it again and change. And this is how we can debug the problems. And fortunately, there is a pipeline editor, and we can have some syntax highlighter for us. Let's check the project, and the pipeline is running, fortunately. And let's say everything is fine for the build directory. And one of the cool thing here that we have to keep in mind is that when the file and directory were generated, you can see there is an uploading artifacts. This means that the runner is uploading the artifact to the GitLab service, and in the sidebar we can see the artifacts are available here. I can download the artifacts, I can browse the artifact repository for this job, and this is the build directory, and this is the app.txt file that we generated in our job. How cool is that? And then we can check that the app test, the first job is succeed, and we have to wait for the second one. And obviously the second one should be succeed as well, because now uh, the second test have access to the build directory as well. So to recap, we learned how we can define the stages, how we can define different jobs, how we can group them in stages, how the jobs in a stage will be executed in parallel. We can add as much as stages that we need. And the final point is that there are 5 stages that are defined by default by GitLab, not just these 3, but feel free to use the name of stages as you need, but conventionally you can use these names in your projects. The other 2 stages that are that are defined in GitLab by default is some special names. The first one is pre, and the final one is post, if I'm not mistaken. And the pre is something that will be executed before any of the stages that are going to run, and the post is the stage that will be run after the completion of all previous steps. So keep in mind that pre and post are the other stages that are defined. So if I'm using build and test here, I can simply remove it, remove this part, because GitLab already will created these stages for us, and is something optional to define them or not. So that's it. Hope you liked the video, and in the next video, we hope we will talk about the configuration for merge requests.